All right, so last time we created a composition that generated some random shapes on our screen, right? So we have a triangle, we have a rectangle, we have a circle, and the colors were generated randomly. The position of the points on the triangle are generated randomly. So this is the code that we wrote for this. And now let's move on to the next step. Let's take it a little further and let's see if we can sort of split up our composition, our canvas, into several sections, and then have this composition be repeated with slight variations from section to section to section. So what I'm going to do is I'm going to slice my screen into a certain number of columns and rows. Let's say 5 columns and 5 rows. And actually, I'm gonna tweak that number a little bit, and you'll see how we do this. So several numbers, several columns, several rows, and then we are going to, within each cell, in the columns and rows, we're gonna generate this composition, and we're going to tweak it and add slight variations from one cell to the next, to the next, to the next. Okay, so we're gonna be building it from here. So let's start by slicing things up, right? So typically, if you want to slice things up, or if you want, so slicing things up simply means repeatedly drawing vertical and horizontal lines. Let's just start there, right? So in order to do this, we're going to need to create a loop, right? This is hopefully something that you're familiar with from some basic JavaScript, but to remind you, a loop is a way for you to do something over and over and over and over again, right? So the most common format for a loop would be a for loop, right? So let's say I want to create a certain number of columns, let's say 5, right? And so I will say, I want to run a for loop in order to do this. And in the for loop, I'm gonna set up my starting condition, right? So since I'm doing columns, I'm doing verticals, I'm gonna create a variable and call it x, right? And we're gonna start at 0, right? And 0, if you remember, is at the top left corner in processing. So we're gonna start on the left at the 0 point, right? So then I'm gonna set up my final condition. So when am I gonna stop? I'm not going to run it endlessly. It's actually a big error in your program if your loop runs endlessly. So my final condition is going to be when the x is either reaches or exceeds, right? So it's greater or equal to, or sorry, in this case, less or equal to the width of my sketch. So starting with x equals 0, for as long as x is less or equal to width, I'm gonna execute my loop and then do something with my x, right? So there's like this big, like, what am I gonna do with my x, right? And so what I'm gonna do in the loop, so every time I go to the next step, all of this operation is gonna be run within, between the curly brackets, right? So the big question now is I want to jump a certain number of pixels. So let's say I want to start at, well, let's do something like this. Right, so this is if you remember the coordinate system. So let's start with my actually, I'll do the, so this is my sketch, right? And I'm gonna start with my x at 0, right? So right here. And then I want to jump, like, let's say I want to start with 5 columns, right? So this is width, this is my ending condition, and I want to divide it into 5. So how do I figure out how many pixels do I need to jump in order for me to have 5 columns like this, right? So it's clearly width divided by 5. But that's supposed to be 5. Sorry, let me just clean that up a little bit. So that's going to be width divided by 5, right? And so if I wanted 6 columns, I would divide by 6. If I wanted 10 columns, I would divide by 10, right? So this number can actually change and become a variable, right? It's some kind of a variable. We can call it the number of lines or the number of columns or whatever, right? Let's call it the number of lines. So let's create our variable. So a variable is basically, so we already have one right here, the x variable that's going to represent our position for on the in the horizontal plane, right, on the x-axis, our position as we're going from one to the next iteration of our loop, right? And so this variable we declared inside our loop, but the variable for the number of lines is kind of independent. I can set that up for the entire sketch, for the entire environment. So what I'm going to do, I'm going to actually declare that variable outside of even a setup function in the very, very beginning. So I'm going to go here and say let number of lines, and we'll start with 5, right? So our width needs to be divided by the number of lines, and then our x will become whatever it was plus that number. So let's say we have 800, and if I wanted to, just for simplicity of calculation, if I wanted to draw 8 columns, I would need to divide 800 by 8. Each column would be 100 pixels wide. So in the first iteration, my x would have to be equal to 0, right? So let's just illustrate this real quick. Let's remove all these guys. So on the first iteration, my x would be right here, would be 0. Then I say width, yeah, that's not what I expected. So let's clear all this up, and let's say width divided by 8. And if width is 800, it's going to give me 100 pixels, right? So I'm going to say, okay, so for the first run, it's going to be 0. Then I want to say wherever I was, so it's 0 plus 100. So jump over here. So now the x is at 100. Then I want to say for the next iteration, I want to be wherever I was plus 100 more, right? So if I was at 100 plus 100 more, I'm going to be at 200. Then 200 plus 100 more, I'm going to be at 300, and so on and so forth. So for every iteration, my x needs to increment by this number, right? And this number is signified by the width divided by however many columns I want. So we can express this in code as follows. X is equal to x plus width divided by number of lines. So the number of lines, so this component will give us the width of every single column, and then we're going to say, so whatever x was plus that number, that's going to be the new value of x for the next iteration of our for loop. Okay, let's just start with something simple. Let's just draw some lines. Okay, so what I'm going to say, if you remember, if we go into our 2D primitive reference, there is a line, right? And a line is a 2D primitive. And just like with the triangle, you can draw a line by specifying the points that make it. x1, y1, so x coordinate and y coordinate for the first point, and x coordinate and y coordinate for the second point. Okay, so I want to draw a line from the top of the screen to the bottom of the screen, right? So that means I'm going to draw a line right here, and it's going to be at whatever the x value is at this point, and then the top screen is 0, and then whatever the x value is at this point, and then the y value is going to be height for the bottom of the screen, right? So when x is 0, I'm going to start at 0, 0 point and go down to 0 height. When my x is 100, I'm going to start at 100 by 0 to full height by 0, right? So if you run it like this, and right now we have 5 lines, we have 1, 2, 3, 4, 5. 5 columns. Fantastic, right? And if I change this to 8, now I have 8. Even better, right? So, very good. We figured out how to divide our space into a certain number of columns, and we can do the same thing for the number of rows, right? I could just take this exact for loop, copy it, paste this right here, and then change the name of my variable to y, because this time I am going to be moving vertically instead of horizontally, right? And so it's going to be height, and then again we're going to change x to a y and x to a y, and it's going to be the height. And then the line will now be formed, instead of being drawn vertically, I'm going to draw it horizontally. So I'm going to start at x equals 0, and then whatever the value of y is, and then again, it's going to be, x is going to be always at width, and then again, whatever the value of y is, right? So a very similar idea. I'm going to start somewhere here. So x0, y is my value, and then move across, and then x will be at width, and y will be whatever my value is, right? So here I have a grid. That's fantastic. So right now, I have a bunch of vertical lines and a bunch of horizontal lines drawn completely independently from each other. So I have kind of like a vertical grid and a horizontal grid, and just one is drawn on top of the other, right? If I make one small variation though, I can nest one grid inside the other, right? And that variation is going to be quite critical. I am going to take this for loop and I'm going to nest it inside the first for loop. So I'm going to cut this out and I'm going to put it right here. So like that. So my for loop is actually going to be inside the other for loop, right? And so I don't need to draw the line now separately. I'm not going to draw the entire horizontal line, or sorry, entire vertical line and then entire horizontal line. I'm just going to draw a line from the beginning of the section to the end of the section, because first I'm going to move, so my big loop, my outer loop, is going to move me through columns, and the small loop inside is going to go through row for each column. So you can think about it this way. So let's go back here, and I am going to start with my outer loop, my x value, right? And so that's going to draw me a column like this. And then inside this column, I am going to start going like that, right? I'm going to start separating different sections. But I'm going to take it one step further, and I am even going to draw my column one piece at a time, like so. And then another, and here, and then another, and here, and then another, and here, and like that, right? And then I can switch my x over to the next value and start running. The x value is going to stay, but there's a whole bunch of y level for loops that are going to keep running, right? So you can think about this movement as being created by the outer loop, and this movement being created by the inner loop. So what that means is I'm switching these, I'm making these jumps, right, like this, but with the inner loop, with this one, and I'm making the outer jumps, the big ones right here, with the outer loop, the one that controls my x. Okay, so let's see how that works. So I'm still going to need to draw 2 lines, but my lines are going to be slightly different, right? So here's how my lines are going to run. I'm going to draw line, and then I'm going to draw line from the x point and the y point, right, to whatever the x is going to be next. So x plus this interval, and then whatever the y is going to be next. So y plus this interval, right? So this is going to create a whole bunch of diagonal lines for me. So I'm going to now separate the two, but let's run those diagonal lines first, and that's going to be basically, the movement is going to be like that, right? So it's going to create a whole bunch of these diagonal lines, right? And then I'm going to separate those diagonal lines into 2 separate components. So if I run it like this, a bunch of diagonal lines, okay? So now I need 2 lines, each one then going first. So instead of doing this, 1 line diagonally, I want to do first this and then this. So in the first loop, the x is going to be different, but the y is going to stay the same. On the second line, the y is going to be different, but the x is going to stay the same, right? So let's see how we can implement this. So I'm going to have 2 lines. And so on the first one, we said that the x is going to be different, but the y is going to stay the same. So I'm not going to change the second value of y. It's going to stay the same. On this one, though, y is going to change, but x is going to stay the same. So I'm not going to change the second value of x, right? So if we run it like that, we're back to the grid, but each line only exists locally, forming a separate cell right here. So, and each separate cell I know exists between within this set of coordinates, x and y, x plus the number, plus the width divided by the number of lines, and y plus the height divided by the number of lines. So this gives me my local coordinate system. This is really important, right? So again, to illustrate this here, I am drawing from this point to this point, right? And this gives me my local coordinates, because now I can start saying, okay, so this is how my cell is formed, from this top left corner to the bottom right corner, right? And I can identify how to make this corner, I can identify how to make this corner, and I have my own local little coordinate system, which allows me to place elements within each cell. Okay, perfect, really great. So let's see how we can utilize that local coordinate system, right? So first of all, saying this like whole x plus the width, number of lines, whatever, right, is a little cumbersome. So I'm going to create temporary values, and I am going to say, so like my let next x be something like this. Oh, need the whole thing. So this is going to be my next x, and then I can say from x to next x, right? And then my next y is going to be this whole expression, and I can now replace this with my next y. So this makes it a little bit easier to kind of wrap your head around. So I'm drawing a line from x and y to the next x but the same y, and then from x and y to the same x but the next y. Okay? So those are my lines. And now I can start taking this like whole large composition, kind of like squishing it down and making it dependent fundamentally on the local coordinate system, right? So let's try this out. So first of all, let's do this one quick thing. So every time we run it, it's going to be slightly differently, but let's see what these values of next x and next y come up to, because it can be very useful for you to figure out where exactly are you located. And so this for this you can use your console, right? So let's say I want to find out my value of x and my value of y at any given point as my code runs, right? So I can say console, right? So I'm going to address this console and say log. So into the log of my console, I want to output the words next x column space and the value of the next x, right? So this is text because it's inside the quotation marks, right? And this is the actual value of x plus width divided by the number of lines. And I can do the same thing for y, and you can see how we're kind of like stepping in one column through all the y's several times, and then in the next column through all the y's several times. So let's run it like this, and we have a whole bunch of stuff in the console, right? So this is how many cells we have. So first time, next x is 100, next y is 75. Second, so this is our first cell right here. Then next x remains 100, correct? Because we're going down that column, and the y is 150. And then we still on the same column, so our next x is still 100, but the y is now 225. Then x remains at 100, but next y is 300. And so on and so forth, and we just keep going down this first column until we reach the end of it. And you can tell that we've reached the end of it because once we say x is 100, y is 675, but that's when we run out of y because we can't exceed the height. And we switch over, and now x becomes 200, and y is back to 75. And it's 200, 150, 200, 225, 200, 300, and so on until we, again, go down to the bottom of this loop. X is 200, and then y is 675, and we can't exceed that, so we move to x being 300. And then it's 75, 300, and 150, 300, and 225, and so on and so on and so on, right? So that way we step through each one of those cells one by one. Okay, so this console log trick can be very, very helpful for you to try to understand how your code runs. And if you're doing something unexpected, maybe it will be helpful for you to even figure out how exactly to fix it, right? And like it could provide you some hints in your debugging detective work. Okay, so let's put our composition, but now all of our shapes are going to be situated within the cell, right? So like the big numbers like 400 and 300 are out, and the values that are dependent on the entire sketch are also out. So something like center of the entire sketch, right? Width divided by 2, height divided by 2, that's also out, right? And we won't be able to use the width inside our triangle. So we'll try something else. So let's start with the rectangle. So we'll do that, and then we'll paste this in here, right? So I can comment this out, and just so that the code doesn't execute, but I might keep it for safekeeping or for later purposes, right? But it's just going to be some text that's not going to be executed as code. In order to do this, you can on a Mac, you can press Command/. On Windows, you can press Control/, right? So with these two lines highlighted. If I do that, it will put the double slashes in front of each one of the highlighted lines, and you will see that the text turned gray, which means that it's not going to be executed, but you can keep it within your code and, for whatever reason, for safekeeping or for later use. Right, so now my rectangle is not going to be always drawn from 100 to 100 point, right? Not from right here. I want to draw it from whatever is the pixel value of my x. So whether it's 0 or 100 or 200 or 300 or whatever that might be, right? And then plus some small number. So maybe it's going to be something like x plus 10, right? And then my y location is going to be y plus 15, right? So again, some small number, because if you notice that our distances between the cells are not that great. And so the width of my rectangle can be something like 40 by 30. I'm just going to make it significantly smaller, right? So let's run it like that and see what happens. All right, so I have a bunch of rectangles all in the same position, right? But they all have different colors. Why? Because every time I draw this rectangle, I generate a random color within the parameters of my randomness, right? So that's great. We have a whole bunch of rectangles that look exactly the same, but are generated with a random color. Excellent. So we can do something similar with a triangle, right? Where we copy this. And again, we can comment this out. And we can still reuse this very attractive randomness that we used for a triangle, right? So it's kind of like independent, and every triangle is going to be slightly different. But now we just need to set up a different range. And the range for the x values is not going to be between 0 and width. The range for the x values is going to be between whatever the x is and whatever the next x is going to be, right? So that's going to be the minimum and the maximum, and I can copy this and start replacing all of my width parameters for the random with the x to next x, and similarly my height can be replaced with y to next y, right? Do this, and here, and here, right? So if I run this like that, ooh, a whole bunch of different triangles. All different colors of different triangles, different. Every cell has a completely different triangle, right? And then, so it's completely random, it's completely unpredictable. But what if I want to have some kind of predictability, right? Some kind of progression, predictable progression within my composition. So that's something I can do with a circle, right? Let's copy this, again, comment this out, command slash or control slash if you're on Windows. And then for the circle, what I'm going to do, instead of specifying its position by width and height, I'm just going to say, I'm going to say that it's going to be in the center of every cell. So I'm going to say next x minus x, right? So that's going to give me the width of my cell. Alternatively, I can also say width divided by the number of lines, right? So that's going to give me the size. That's very much an option. And then I can take this number and then divide that by 2 and then say x plus that, right? So that's starting from the x point by half of the cell size. And I can do the same thing with a y, right? So it's just kind of like a way to express a certain idea that I want to start at the y point and then go by half of the height of my of my cell, right? So 10. All right, so I have an error right here, and it's probably not a bad idea to investigate a little bit what the error is. So I'm gonna take us back to the previous time when we talked about the opening and the closing parentheses, right? So this is where it could be helpful. It's telling me that it expected an operator and saw something, okay, and then it's telling me that it's like missing a semicolon or a function call. So it's not super helpful, but it gives me hints that it's something on this line, right? So let's start looking at this line. So one thing I see is that, like, obviously the circle needs 3 numbers. So I have one number here, I have a number now, another number here. So let's just give it some kind of a number and see if it goes away. Let's give it 10. No, it doesn't go away. So then the semicolon is not an issue. It's JavaScript, so it's kind of feels a little bit odd that it's giving me that that error. And this is something that you're going to encounter. You get some kind of an odd error. That why is it even there? It doesn't sound right. It doesn't sound like this error should be here. So this is when you can start kind of like seeing, hey, where is my opening and closing parentheses? Remember, so if you put your cursor next to a parentheses, it should highlight its counterpart. So if it's a closing, it should highlight the opening parentheses, and if it's an opening parentheses, like right here, it will also highlight the closing parentheses, right? So if I hover it over here, I don't really see the highlight. There's something wrong, right? And that gives you a hint. So if I go right here, that's when it becomes actually quite apparent. If I go to the opening parentheses of my circle, it seems that my circle function is closing too early. And I made this very, very common mistake that I started placing numbers either inside the wrong parentheses or outside of the parentheses when I needed to be placing them inside. So fundamentally, what I wanted to say was not have this parenthesis here. I just wanted to take the width divided by the number of lines and then divide that number by 2 and then add the x to it, right? And then move on to my next number. But instead I put a parenthesis in there as if I'm closing it, right? And the same thing, since I copied and pasted that number, the same thing propagated over here. So I actually don't need this parenthesis. Right, and so this is the kind of investigative work that you need to do sometimes in order to figure out why things are working or not working, so or working the way they're not supposed to be, and why you're getting a particular error message. But pay attention to where your parentheses are opening or closing, how many numbers you're putting into a function, how many numbers does a function expect, and so that kind of stuff. So what we wanted to do, we wanted to iterate the diameter of my circle depending on which column I'm in. So right now, if I'm going to draw my circles like this, you can see that there is a small little circle with a diameter of 10 pixels in each cell in the center as I intended, but it's not actually changing its size based on the which column I'm in, right? So this is where there's several ways to solve this, and feel free to derive the column number from the value of x, right? Let's say we have, if our x is equal 100, how can I derive the fact that we're in column number 1 or column number 2 or something like this, right? So how can I derive this value from the x? There is a mathematical expression, but there's always a better way. And since we've already talked about variables, right? Or maybe not better, maybe just a different way, right? So we talked about variables. So that's something that we can store in the variable. So the very first time we run our loop, we're going to create a little variable called column number and set it to be 0, right? And then so this is our closing parentheses for this inside for loop, right? For this one. So after we're done with that for loop, after we ran it a few times, so like we went through all the cells in the column, we're gonna move on and iterate our column number to the next. So col number equals itself plus 1. Right? So this is a very, very common practice. You will see it in various situations. In fact, it's so common that there is a shorthand for this type of an operation. And that shorthand is simply to say column number plus plus. Right? So adding 2 pluses after the column number will just increment it by a value of 1. Okay? So very, very common operation, but we can also say that we can use this column number and multiply it by 10. Oops. Or plus 10, depending on how you want it to progress, right? And then so on the first, in our first column, our column number is 0. And so 0 times 10, our circle is going to be 0, right? So we're going to have just dots or like nothing. It's going to be points of nothingness. On the second column, or column, let's call it column number 0, then column number 1 is going to be 1 times 10. Column number 2 is going to be 2 times 10, and so on. So this is, again, very, very common thing, and visually, you can immediately see the difference. Ooh, something went wrong. Something went wrong. Let's find out what went wrong, right? So common thing, things go wrong. I'm going to comment out this next y and next x thing, right, that we used. And what I'm going to do, I'm going to console.log column number. What is my column number for each one of the columns? Ooh, it's always 1. 9 times, it's 1 9 times. Interesting. Aha. Why is that? Well, it is 1 for one very simple reason. Because at the end of this for loop, when I increment it by 1, I return to the beginning of the for loop, right? So after I execute line 29, I go back to line 9. And so my column number becomes 0 again. So I add 1 to it, and then it becomes 0 again. I add 1 to it, and it becomes 0 again. So I kind of like keep it stuck in the loop. That's unfortunate, but there's a way around it. And the way around it is to just take this declaration and take it outside of the loop. So we don't come back to it. So we start with a 0, yes, but then we don't come back and reset it back to 0, right? So we just keep adding 1 to it. So in this case, you can see the circles growing. You can see the progression from left to right, and it's also reflected in here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And if we change the number of lines right now, if you remember, we're dividing everything into 8 columns and 8 rows. So if I change this to 5, the entire cadence is going to change. Now I have fewer sections, smaller progression of circles, right? The entire sort of composition change. And so this is another very important concept, right? That you can have one kind of like pivot point, and everything hinges on that point, and everything starts working off of this one single point, and therefore things start changing based on how that point is moving and translating. So this is something that I think would be interesting for you to think about. And another thought that I wanted to leave in your head is like, try to think about what would you do to create a different background in each and every cell. So I'm going to give you the solution in just a second, but if you want, just give it a pause and then try to think about yourself, and then unpause it, and then I'll give you the solution. All right, so here's the solution. So remember in the previous videos, I talked a couple of times about this like little sleight of hand that we can do. So this is where that sleight of hand can come handy, right? So leverage the fact that there are shapes that are drawn on top of other shapes. So if I wanted to change the background of every cell, what I can do, I can just create a rectangle. First thing, the moment I approach my cell, the very first thing I can do, right, after I created my lines that create the borders, I can create a rectangle. That rectangle is gonna start at the X, Y position, right? So at the top left corner of my cell, and it's gonna extend, its width is gonna be the width and the height of every cell. So it would be this number. So width divided by the number of lines, and then this number, height divided by the number of lines, right? So this will give me a rectangle, and now I can add, so it will start right here, for example, or right here at this point, and then extend. This is going to be the width, and this is going to be the height. And then I can add the fill, and this time let's make it random on a different value. Let's make a random red value, right? So I'm going to say random between 0 and 255, and 0 is implied. And then here I'm going to say 120 and 160. Right? So this is going to give me a random value for every rectangle in every cell. And that way, here we go. It looks like that every cell is changing its background. In fact, what's happening is I'm just drawing a rectangle that's the size of that cell and changing the color of that rectangle. Okay? All right, so that's it for today. Next time we are going to talk about animation and making things move. Play around with this idea, try to create something yourself, and have some fun with it.